Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Have you ever wondered how bright the universe can get? Is it even possible to see something so intense that it outshines everything we've ever known? What if there was an object sitting billions of light years away, emitting such an overwhelming amount of energy that it could dwarf entire galaxies? This might sound like science fiction, but it's exactly what scientists have discovered. Recently, astronomers detected the brightest object ever seen in the universe, a quasar so luminous it outshines everything we've observed before. This object, located an astounding 12.8 billion light-years away, is a beacon from the very early universe, a time when the cosmos was just beginning to take shape. It's called JADES G S Z 13-0, and its brightness has stunned the scientific community. But what does it mean for us, and why is it such an incredible discovery? To fully appreciate the magnitude of this find, we need to dive into what a quasar actually is. A quasar is not just a random star or galaxy. It's the energetic heart of a galaxy, fueled by a supermassive black hole. Imagine a black hole millions, sometimes billions, of times the mass of our Sun. Surrounding it is a swirling disk of gas and dust, drawn in by the black hole's immense gravity. As this material spirals in, it heats up to unimaginable temperatures, millions of degrees, emitting an extraordinary amount of radiation. This is the light we see from quasars, and it's not just any light. This radiation is so intense that it can outshine the entire galaxy it resides in, making quasars the brightest objects in the known universe. But JADES G S Z 13-0 isn't just any quasar. It has completely shattered previous records. It's brighter than any other known quasar by a significant margin. To put it in perspective, the light emitted by this single quasar is so intense that, if it were placed within our own Milky Way galaxy, it could outshine the entire galaxy by a factor of 1,000. Imagine looking up into the night sky and seeing a single object so powerful that it would make even the brightest stars look dim in comparison. That's the scale of brightness we're talking about. But how did we even spot this object? 12.8 billion light-years is an unfathomably long distance. The light from JADES G S Z 13-0 began its journey to us long before Earth even existed. The answer to this incredible feat lies in the technological marvels of modern space telescopes. Specifically, the James Webb Space Telescope, JWST, played a crucial role. Launched in 2021, JWST has been a game-changer for astronomical observations. With its unprecedented resolution and sensitivity, it can capture light from some of the most distant and ancient objects in the universe. This is the power of looking back in time. JWST allows us to peer into the very early stages of the universe when it was just a few 100 million years old. What makes JADES G S Z 13-0 so fascinating is that its light comes from a time when the universe was only about 700 million years old, just a fraction of its current age. In fact, this quasar is one of the most distant objects ever discovered, placing it in the era known as the Cosmic Dawn. This was a time when the first stars and galaxies were beginning to form, and the universe was still in its infancy. The light from this quasar gives us a rare glimpse into a period that's otherwise hidden from us, a time when the universe was vastly different, yet still laying the groundwork for the cosmos we know today. But beyond just being a record-breaking discovery, JADES G S Z 13-0 is opening up new questions about the nature of the universe. Scientists have long debated how black holes grow so massive. After all, a supermassive black hole like the one at the heart of this quasar contains the mass of billions of suns. It's a mystery how such monstrous black holes could have formed in the early universe, so soon after the Big Bang. The discovery of this quasar is providing new clues. One possibility is that these early black holes grew quickly by merging with other black holes or by rapidly pulling in enormous amounts of gas. But there's still a lot we don't understand. The rapid growth of such a massive black hole so early in the universe challenges many of the models we have for black hole formation. But what makes this quasar so powerful? It's all about scale and velocity. The material surrounding JADES GSZ is traveling at speeds that are almost incomprehensible. Gas in the accretion disk of the black hole is moving at speeds approaching a significant fraction of the speed of light. This creates immense friction and heat, which generates the tremendous radiation we see. The energy released by this quasar is so vast that it could outshine an entire galaxy, and yet it's coming from an object smaller than our own solar system. It's almost hard to fathom. The discovery of JADES G S Z challenges our understanding of the universe's early days. How did black holes form and grow so quickly? What role did they play in the formation of galaxies and stars? And what does this mean for our understanding of cosmic evolution? These are just a few of the questions scientists are now racing to answer. This quasar is not just another distant light in the sky. It's a cosmic beacon that could help us unlock the mysteries of how the universe evolved from a hot, dense, chaotic state to the vast and complex cosmos we observe today. As we continue to study objects like JADES G S Z, we're not just learning about distant stars or galaxies, we're learning about the very forces that shaped the universe itself. Every discovery like this takes us one step closer to understanding the ultimate origins of everything we see around us. And as we venture further into the universe, who knows what other astonishing sights await us? This journey is only just beginning, and you're right here with us exploring the cosmos together. Now that we've established just how extraordinary JADES G S Z is, let's take a deep dive into the forces that make it so powerful. To understand what gives this quasar its mind-boggling brightness, we need to get to the heart of the action, the supermassive black hole at its center. Imagine, if you will, the chaos at the very core of this quasar. A supermassive black hole with the mass of billions of suns sitting at the center, quietly pulling everything into its gravitational grip. This black hole isn't just sitting there, minding its own business. It's an active monster, devouring gas, dust, and even entire stars that venture too close. And as it does, it unleashes an unimaginable amount of energy, powering the quasar in a way that's almost impossible for us to fully comprehend. The process behind this is called accretion, which is a fancy way of saying that material falls into the black hole, spiraling inward like water down a drain. But here's where things get interesting. As this material falls, it doesn't just fall in quietly. It heats up, friction builds up, and the gas in the accretion disk, this swirling disk of hot, dense material, begins to glow brightly. The closer the material gets to the black hole, the faster it moves and the hotter it gets. Some of this gas can reach temperatures of millions of degrees. In fact, the temperature in this accretion disk is so high that it emits light across a broad range of the electromagnetic spectrum, including visible light, ultraviolet, and X-rays. But here's the real kicker. This energy doesn't stay confined to the disk. Some of it escapes, blasting out into space in the form of powerful jets. These jets shoot out from the poles of the black hole at nearly the speed of light, creating these massive beams of radiation that extend for millions of light years. These jets are some of the most powerful features of a quasar, and they are key to understanding why JADES G S Z is so bright. In fact, it's these jets that help quasars shine so intensely. As they shoot outward from the black hole, they carry with them an enormous amount of energy. When these jets interact with the surrounding material, whether it's gas, dust, or even other galaxies, they can create massive shock waves that release even more energy. This process amplifies the brightness of the quasar, making it one of the most luminous objects in the universe. These jets are so powerful that they can have a huge impact on their host galaxies, potentially altering their structure and preventing new stars from forming by blowing away gas and dust that would otherwise be used to create new stars. But the real mystery behind JADES G S Z is the fact that it is so bright so early in the universe. The quasar is located in the distant past, around 12.8 billion light-years away. To put that into perspective, that's only about 700 million years after the Big Bang. This means the black hole at its core was able to grow to such massive sizes in a relatively short amount of time. How did it happen so quickly? Scientists have several theories about how supermassive black holes could have formed so early in the universe's history. One of the most popular theories involves the rapid accumulation of gas during the universe's cosmic dawn. This was a time when the universe was still young and filled with hydrogen and helium gas, an ideal environment for black holes to form. These early black holes may have started out as relatively small stellar mass black holes, but over time they could have accumulated enormous amounts of gas from their surroundings, growing rapidly into the supermassive black holes we see at the heart of quasars. Another possibility is that black holes like the one at the center of JADES G S Z 13-0 formed through the merging of smaller black holes. The early universe was a turbulent place, full of chaotic events like galaxy mergers and star collisions. In these extreme environments, black holes could have collided and merged, creating even larger black holes in the process. It's possible that this merging process allowed the black hole at the heart of this quasar to grow to its massive size so quickly. But here's the real kicker. If we can figure out how JADES G S Z 13-0 formed and grew so rapidly, we could learn a lot about how supermassive black holes shape the evolution of galaxies. These black holes don't just sit there doing nothing. They can influence the entire galaxy they reside in. For example, the energy released by the quasar can actually stop new stars from forming by blowing away the gas needed to create them. This feedback mechanism has a profound impact on the way galaxies evolve. What's even more mind-boggling is that the discovery of this quasar challenges some of the long-held ideas scientists had about black holes. For years, astronomers believed that black holes grew steadily over billions of years, slowly pulling in gas and building up their mass. But JADES G S Z 13-0 seems to defy this idea. This quasar is so bright and so powerful that it's forcing scientists to reconsider their models of black hole growth and evolution. Could black holes grow faster than we ever imagined? And if they can, what does that mean for the way galaxies form and evolve? This discovery also opens up new questions about the relationship between black holes and the early universe. The light emitted by JADES G S Z 13-0 provides us with a snapshot of the universe's infancy, a time when galaxies were first beginning to form. If quasars like this one were common in the early universe, they could have played a huge role in shaping the universe's first galaxies. In fact, some scientists believe that the energy from quasars might have helped ionize the universe, turning the opaque fog of neutral hydrogen gas into the transparent medium we see today. The implications of this discovery are far-reaching. By studying quasars like JADES G S Z 13-0, we can learn about the early universe, how black holes grow, and how galaxies evolve. We're not just looking at an ancient object. We're looking at the very processes that shape the cosmos as we know it, but there's still so much we don't know. The discovery of JADES G S Z 13-0 has raised more questions than answers, and scientists are eager to unravel them. What did the early universe look like through the lens of these quasars? How did the most massive black holes form so quickly? And what secrets are hidden in the energy and jets they emit? Astronomers continue to study quasars like JADES G S Z 13-0. They are peering deeper into the heart of the universe itself. The answers to these questions could change the way we view the cosmos, and who knows what other surprises await us as we continue to explore the vast unknown. Imagine traveling back in time, not just thousands or millions, but billions of years. What would you see? The universe as we know it today was once very different. The galaxies, stars, and even the very elements that make up our bodies were still in their infancy. The discovery of JADES G S Z 13-0 gives us a rare and astonishing glimpse into this cosmic dawn, a period of rapid change and evolution in the universe when it was only a fraction of its current age. Around 12.8 billion years ago, when JADES G S Z 13-0 first began shining, the universe was still in its early stages. The Big Bang had occurred just a few 100 million years prior, and the universe was still emerging from the haze of its birth. This was a time when the first stars were forming, giving birth to the very building blocks of galaxies. The early universe was a chaotic, dense and turbulent place, like a boiling cauldron of potential energy waiting to cool and coalesce into something more organized. At this point, the universe was filled with hydrogen and helium, the simplest and lightest elements. These elements had formed in the first few minutes after the Big Bang, during a period known as Big Bang nucleosynthesis. But despite these elements being abundant, the universe was still dark, because there were no stars or galaxies yet to light up the sky. This period of darkness lasted for hundreds of millions of years and is often referred to as the cosmic dark ages. During this time, the universe was a foggy, opaque place, with neutral hydrogen gas preventing light from traveling freely. But then something remarkable happened. The first stars began to form. These stars, known as population 3 stars, were incredibly massive and short-lived. They fused hydrogen and helium in their cores, creating heavier elements like carbon, oxygen, and nitrogen. These stars were the universe's first furnaces, creating the elements that would later go on to form planets, life, and everything we see today. As these early stars burned through their fuel, they released massive amounts of energy, and some of them exploded in supernovae, spreading these new elements across the universe. This was the beginning of a process known as reionization, where the universe gradually transitioned from its dark, opaque state to a more transparent one. But JADES G S Z 13-0, the quasar we're discussing, is a sign of something even more profound. This object is not just a random blip in the universe's timeline. It's a beacon from a time when the universe was just beginning to take shape. The fact that it exists at all suggests that massive black holes were already forming at this early stage, challenging our previous assumptions about the speed and nature of black hole formation. So why is this quasar so important? Because it's offering us a window into a time when the universe was undergoing rapid and fundamental changes. This was a time when galaxies were just beginning to coalesce, and supermassive black holes, like the one at the heart of JADES G S Z 13-0, were starting to exert their influence on the cosmos. The very existence of this quasar suggests that black holes were not only growing rapidly during this period, but they were doing so in a way that we hadn't fully understood before. Let's break this down a bit further. The light from JADES G S Z 13-0 has traveled for 12.8 billion years to reach us. In essence, we're looking back in time, not just observing an object, but peering into the universe's past. The quasar's light is like a snapshot frozen in time, providing us with clues about the conditions that existed during the cosmic dawn. The fact that this quasar exists at such an early stage in the universe's history raises several intriguing questions. How did the black hole at its center grow so quickly? How did the surrounding gas and dust accumulate at such a rapid rate, feeding the black hole and powering the quasar? And what role did this quasar play in the reionization process? To answer these questions, astronomers are looking to simulations of the early universe. These simulations attempt to model how the first stars, galaxies, and black holes formed and evolved over time. And what they're finding is that the early universe was a much more dynamic and violent place than we might have imagined. Instead of a slow, steady build-up of black holes over billions of years, the early universe may have seen black holes growing rapidly, fueled by the vast amounts of gas present in the primordial cosmos. One theory suggests that these supermassive black holes grew quickly through direct collapse. In this scenario, massive clouds of gas collapse under their own gravity, forming black holes directly, without going through the normal process of star formation. These black holes could have been the seeds for the quasars we see today. Another possibility is that these early black holes grew through mergers, colliding with other black holes or gas clouds and rapidly gaining mass in the process. But what really makes JADES G S Z 13-0 stand out is its extreme luminosity. Even in the early universe, we're seeing quasars that are so bright they can outshine entire galaxies. Why is this the case? The rapid growth of these supermassive black holes could have triggered violent feedback mechanisms that affected their surroundings. As the black hole accreted material, it may have expelled vast amounts of radiation and powerful jets, which would have heated up and ionized the surrounding gas, making the quasar visible from such a great distance. This discovery forces us to rethink our understanding of the universe's earliest days. Before JADES G S Z 13-0, we believed that supermassive black holes took much longer to form. We thought that these black holes needed billions of years to grow to their massive sizes, but this quasar has proven that these objects can form and grow rapidly, changing the way we think about black hole evolution and the role they play in the broader context of cosmic history. The light from this quasar is helping us piece together a more detailed and dynamic picture of the early universe. It's showing us how black holes, galaxies, and stars co-evolved, with these powerful black holes influencing the growth and formation of galaxies around them. The jets of energy and radiation emitted by the quasar could have played a major role in shaping the galaxies around it, potentially preventing new stars from forming by blowing away the gas and dust that would otherwise fuel star formation. In many ways, JADES G S Z 13.0 is like a time capsule, a snapshot from a moment in time when the universe was radically different from how it appears today. And as we continue to study it, we'll uncover more of the mysteries hidden in this ancient light. The discovery of JADES G S Z 13.0 is not just a milestone in our understanding of the universe, it's a springboard into a whole new era of cosmic exploration. What does this incredible find mean for the future of astronomy, and what new questions will it inspire? Now that we know that quasars can shine brighter than ever imagined, in a universe far younger than we thought, what frontiers will scientists push next? First, let's talk about the tools we'll use to explore this new frontier. The Hubble Space Telescope, which has been instrumental in uncovering many of the universe's secrets, is now complemented by next-generation observatories like the James Webb Space Telescope, JWST. But even these cutting-edge instruments are just scratching the surface. While Hubble and JWST have given us mind-blowing views of the universe, their capabilities are still limited by the amount of light they can capture, the wavelength, ranges they can observe, and their resolution. However, the future holds even more promise. The next generation of space telescopes, like the Nancy Grace Roman Space Telescope, promises to push our ability to observe distant galaxies, black holes, and quasars even further. This telescope will be equipped with advanced optics and a much larger field of view, enabling us to study the faintest and most distant objects in the universe. Imagine a telescope so powerful it could peer even deeper into the cosmic past, unveiling secrets of the universe's earliest moments and potentially discovering more quasars like JADES G S Z 13.0. As technology continues to evolve, so too will our ability to explore the universe's darkest corners, and the surprises waiting for us will only multiply. But here's the kicker. JADES G S Z 13.0 isn't the only one out there. In fact, scientists believe there are many more quasars like it, just waiting to be discovered. These objects are incredibly rare, but the more we learn about them, the more we realize how important they are for understanding the early universe. Every new quasar we discover provides another piece of the puzzle, another clue that helps us reconstruct the history of the cosmos. And with the next wave of telescopes, we could find hundreds, maybe even thousands, of new quasars in the coming decades. What could these discoveries tell us about the formation of galaxies and the role that black holes play in their evolution? For one, we might find that quasars like JADES G S Z 13.0 were far more common than we previously thought. If that's the case, it would suggest that supermassive black holes have been shaping the structure of galaxies for much longer than we believed. Quasars could be the key to understanding how galaxies grow and evolve, and how black holes influence star formation, galactic mergers, and the distribution of gas and dust throughout the cosmos. But let's take it a step further. While JADES G S Z 13.0 is giving us a glimpse into the past, the future holds the potential to answer some of the biggest questions about the nature of dark matter and dark energy. We know that these two mysterious phenomena make up most of the universe's mass energy content, yet we still don't fully understand what they are or how they work. But here's the intriguing part. Supermassive black holes like the one at the center of JADES G S Z 13.0 might hold the key to unlocking these cosmic mysteries. Researchers are already speculating that the energy and dynamics surrounding black holes could offer clues about dark matter and dark energy. For example, some scientists believe that the way black holes bend and warp space-time could help us understand the nature of dark energy, which is responsible for the universe's accelerated expansion. If we can learn more about how these supermassive black holes interact with their surroundings, it might give us a better grasp of how dark matter and dark energy influence the universe at large. But this isn't just about understanding the distant past, it's also about looking forward. What role will supermassive black holes play in the future of the universe? As we continue to study quasars, black holes and galaxies, we might eventually discover that these objects are involved in processes that affect the long-term fate of the universe. Could black holes eventually play a role in the eventual end of the universe, as some theories suggest? Will they become the engines that drive the cosmos into its next phase of evolution? Only time and more discoveries will tell. In the meantime, we'll continue to gather data from quasars, black holes and galaxies, piecing together the grand narrative of the cosmos. With every new discovery, we edge closer to answering some of the universe's most profound questions. And the search is only just beginning. For now, though, let's pause and reflect on the fact that we live in an extraordinary time. The discovery of JADES G S Z 13.0 has pushed the boundaries of our knowledge, challenging everything we thought we knew about black holes, the early universe, and the formation of galaxies. It's a reminder that for all we've learned, the universe still holds countless secrets waiting to be uncovered. This quasar, with its immense power and ancient light, is not just a scientific discovery, it's a symbol of humanity's unyielding curiosity and drive to explore the unknown. Every new quasar, every new black hole, and every new galaxy we find brings us one step closer to understanding the vast, interconnected cosmos we are a part of. And who knows, perhaps the next discovery will be even more mind-bending than the last. Maybe, just maybe, we'll uncover something so unexpected, so profound, that it will change our understanding of the universe once again. So as we wrap up this journey through space, I want to leave you with one final thought. If we can peer across billions of light years to uncover the secrets of distant quasars, what other mysteries of the universe are still waiting for us to discover? The adventure is far from over. In fact, it's only just begun.